1. Gravitational force. This is the force of attraction between any two objects that have mass. It's the reason why everything falls toward the Earth, and why planets orbit the Sun. The larger the mass and the closer the distance, the stronger the pull. It's weak in small things, but dominant in space because of the mass of the planets. 2. Frictional force. Friction is the force that resists motion between two surfaces in contact. It can slow down an object or bring it to a stop completely. There are two main types: static friction, which keeps an object in one place, and kinetic friction, which acts on objects already in motion. Without friction, walking, driving, or even holding things would be impossible. Everything would just keep sliding forever. 3. Normal force. The normal force is the support force a surface gives to an object resting on it. It balances out gravity's downward pull. For example, when you place a book on a table, the table pushes back up with an equal and opposite force. Without the normal force, objects would simply sink through every surface. 4. Tension force. Tension is the pulling force that's transmitted through a rope, cable, or string when it's tight. It acts along the length of the material and pulls equally on both ends. You can feel tension when you pull a rope in a tug of war. The rope stays stretched because both sides apply equal force. It's also what keeps elevators suspended. 5. Applied force is any force that's directly exerted on an object by a person or another object. It can push or pull in any direction. For example, when you push a shopping cart, the force comes from your hands. Applied forces are what we use daily to move or control objects, from pressing a key on your keyboard to lifting a box. 6. Air resistance. This is a special type of friction that acts on objects as they move through air. It pushes opposite to the object's motion, trying to slow it down. The faster the object moves or the larger its surface area, the stronger the drag. This is also one of the reasons why moving objects come to a stop after some time. 7. Spring force. Spring force appears when a spring is stretched or compressed. It always acts in the opposite direction of the stretch or compression. The force tries to restore the spring to its original shape. According to Hooke's law, the force increases with more stretch. That means the farther you pull, the stronger it pushes back. 8. Magnetic force. Magnetic force comes from magnets or moving electric charges. It can both attract and repel depending on the poles. Opposite poles attract, same poles repel, like true north. This force is behind how compasses work and how electric motors spin. Even Earth itself is a giant magnet, creating a field that protects us from harmful solar radiation. 9. Electrostatic force. Electrostatic force happens between objects that carry electric charges. Opposite charges, positive and negative, pull toward each other, while similar charges push away. This invisible force acts even without contact, and compared to gravity, it's incredibly powerful. It plays a key role in how atoms stick together and how lightning forms during a storm. Buoyant force. Buoyant force is the upward push that acts on objects when they're placed in a fluid. It always acts opposite to gravity, reducing the object's apparent weight. This force arises because pressure in a fluid increases with depth. The bottom of an object experiences more pressure than the top. That difference in pressure creates a net upward force. The strength of this force depends on the density of the fluid and the volume of fluid displaced.